All right, here's try it 1.51 from PreCalculus OpenStax. We're given two functions and it asks, are they inverses of each other? Lots of different ways you can figure this out. I think what your book had in mind is to take advantage of the fact that anytime you compose a function with its inverse, you should get x as the output. So let's see if that works. If I take f of g of x, does that equal x? Well, I don't know. G of x is equal to the cubed root of x plus 4. So if I want f of g of x, really what I'm asking is what is f of the cubed root of x plus 4? And I can figure that out because I have the blueprint here for the function f. So instead of putting x in and getting x cubed minus 4, I could copy this thing and everywhere I see an x, replace it with the cubed root of x plus 4. So then I get the cubed root of x plus 4 cubed instead of x cubed here minus 4. Let's see, the cubed root of x plus 4 cubed, the cubed root and the cube cancel each other out, so I get x plus 4 minus 4, which sure enough equals x. What that tells me without checking any further is that yes, these two, yes, scream it if you want, these two are inverse functions of each other. There are many other ways you could figure out this problem. Something else you could do is figure out g of f of x. This should also be equal to x. Note, you don't have to check both of these. Just showing you other stuff you could have done. To compose the functions in this order, I figure out g of, well, I know f of x is x cubed minus 4. So g of x cubed minus 4, copy this blueprint here, except everywhere you see the letter x, replace it with what you got in the parentheses here. So I got the cubed root of, and then instead of writing x plus 4, I'm going to write x cubed minus 4 plus 4. But this is just the cubed root of x cubed, which is just equal to x. So I just showed again that the answer is yes. Another exclamation point here if you want. These are definitely inverses of each other. If you don't like either of those two methods, there's other things you could have done. You could have said f of x equals, well, how about just, rather than recopy what's written right here, hello, just write, let's just find f inverse of x. See if that really is equal to this. Well, the way I do that is my first step is I change f of x into a y, so I got y equals x cubed minus 4. And this equation represents the functions, so this equation right here would represent the inverse function. And I can solve this thing for y, add 4 to both sides of the equation, take the cubed root of both sides of the equation. So what I just figured out is that f inverse of x is equal to the cubed root of x plus 4. So yeah, g is f inverse of x. Yeah, that'll work. Probably getting sick of this, but I'm going to do it another way. I'm going to figure out g inverse of x. Same basic method I did here, except now I'm going to start with this function and say y is equal to the cubed root of x plus 4. So let's switch the x's and the y's to get an equation that represents the inverse function. And then solve this equation for y. Cube both sides. Subtract 4 from both sides. So g inverse of x is x cubed minus 4. If you made it all the way through that, that's impressive. You probably would have, I would have checked out after I saw one way to do this. Here's 4 different ways to do one problem. I don't know if it's necessary, kind of beat the hell out of this thing, but I'll call that good.